In today's lesson, we are estimating derivatives of a function at a point. Okay, so here's an example. I have a table with variables time and height, and I've got 0.49 seconds, 0.5, 0.51, and then this is the height at those seconds. 44.1584, 44, 43.8384. Okay, so we're estimating instantaneous rate of change, so estimating the derivative, the slope at this point. So if we're just estimating, all really we can do is find the average rate of change between values. So we can first between these two values and then between these two values and see how close we can get. Okay, so let's look at f of 0.5, the average rate of change between f of 0.5 and f of 0.49 over 0.5 minus 0.49. Okay, so if I subtract these two numbers here, 44 minus 44.1584, the difference there is negative 0.1584, and then I subtract the denominator, 0.01, I'll have an average rate of change of negative 15.84. Okay, now let's find the rate of change between the other two coordinates. So that would be f of 0.51 minus f of 0.5 over 0.51 minus 0.5. Okay, when I subtract these y values here, I get negative 0.1616 over 0.01. And when you divide, we get negative 16.16. So here's the average rate of change before, and then here's the average rate of change after. So if we're just estimating, we want to get as close as possible, we can just average those two numbers. And when you average them, you get exactly negative 16. And I guess I didn't actually say this before, but this is in seconds, this is in feet. So negative 16 feet per second. Okay, similar idea on a graph. Let's look at x equals 1 and see if we can estimate the instantaneous rate of change at x equals 1. So we can look before that. Here I've got from 0 to 1, and then I can look from 1 to 2. So I've got the points 0, 8, and the difference between that, and then I've got the point 1, 5. And then we can look from 1, 5 to 2, 0. All right, so difference in my y values, 5 minus 8 over 1 minus 0. So negative 3, and then here, difference in my y values over difference in my x values. Okay, so the rate of change from 0 to 1 is negative 3, and then from 1 to 2 is negative 5. If you average that out, I can estimate that the instantaneous rate of change is negative 4. So not perfect, but we are estimating. That's what we're doing. All right, now I'm going to show you how your calculator can take derivatives at points for you, and we're estimating by simply rounding. So if I have the function f of x equals x times the square root of 7 minus x, and I want to find the rate of change at x equals negative 2. Okay, so I hit the math button and then the 8th one down. So math 8, put in your variable, take the derivative d over dx plug in your function, x times the square root 7 minus x. At what value? Boom. So the derivative of f of x at -2 is equal to 3.333. All right, the next example, we're going to do the same thing, but then we're also going to write the equation of the tangent line. So f of x equals 4x over natural log of x at x equals 4.7. So same idea, hit math 8, plug in your variables. So I've got x, alpha y equals, enter 4x over natural log of x. And then at the x value, x as 4.7. So that means the derivative of f at 4.7 is 0.914 if you truncate, or 915 if you round. Okay, so what is that? I want to now write an equation of the tangent line using the y minus y1 equals m times x minus x1. All right, so, well, here is my x1, and then the derivative here, this is my m, so I need to find my y1. Well, to do that, I can just plug into f of x, and I will get that y equals 12.148. So then equation of the tangent line at 4.7 is y minus 12.148 equals the slope 0.915 times x minus the x value 4.7. Okay, there's your full video on estimating derivatives of a function at a point. Good luck with your lesson.